For the assembly of figure, knowing that RA is equal to RB, determine the angle of rotation of end E of the shaft BE when the torque T is applied at E. So here we'll have to find out the angle of twist of the shaft BE at the end E. So here we know that the angle of twist is equal to sum of the angle of twist in a series of the shafts, but here the angle of twist is related with the shaft AD also, isn't it? So that here the torque while the gear B rotating, A also rotates, and then the shaft AD also twisted to some amount. So now the angle of twist at E is nothing but the angle of twist of ED, which is equal to the angle of twist EB plus the angle of twist AD. But here the only known values are RA is equal to RB. Therefore, the torque applied on the AD is equal to the twisting moment applied on the EB. So the twisting moment applied on the EB is nothing but T. So sorry, the torque applied on the AD is equal to 2 times the torque applied on the BE. So torque applied on the BE is equal to T. So that it is equal to 2T. Now the angle of twist is nothing but TL by JJ. So here, so that here the angle of twist in AD is equal to TL by JJ. But we know that the amount of twist, deflection is equal for both A and B. That is theta A into RA is equal to theta B into RB. But here we know that RA is equal to RB. So that here theta A is equal or 2 theta A is equal theta B. So that here theta B is equal 2 times 2TL by J. So that is 4TL by GJ. So this is the total angle of twist till the B to D. So you can say that theta B by D. But here the total angle of twist is equal to theta EB plus theta AD. But here now it equals to theta E is equals to theta B plus theta B by E. So theta B is nothing but theta B with respect to D, and here we'll have to calculate theta B with respect to E. Here theta B is equal to 4TL by GJ, and here theta B is equal to just TL by GJ, which is equal to 5TL by GJ. So this is the total angle of twist at E. A cantilever beam of span 3 meter is carrying a UDL over a span of 1.5 meter from the fixed end. If the slope at the free end is found to be 5 degrees, then the slope at the midspan of the beam is. So here a cantilever beam is carrying a UDL over a span of 1.5 meter, but the total span of the beam is 3 meters. That means here this UDL is carried out by cantilever beam till the midpoint. So that here it is given that the slope at the free end is found to be 5 degrees, then the slope at the midspan of the beam is. So here at the midspan of the beam means at the 1.5 meter from the free end or 1.5 meter from the fixed end. Here between the midspan and the free end there is no load acting on the beam, then there is no slope between the free end and fixed end. That means here the slope is constant from free end to midspan of the beam. So that here whatever the slope at the free end is equal to the slope at the midspan. So that the slope at the midspan is 5 degrees. A hollow shaft of length 1.5 meter having moment of inertia 1.4 into 10 power minus 6 meter power 4 carrying 2 point loads of each of 50 kg mass located at 2 different positions from left end and uniformly distributed load of 24.34 kg per meter over the entire length. Static deflection due to the point loads are 70 into 10 power minus 6 meters and 123 into 10 power minus 6 meters respectively. If Young's modulus of the material is 200 gigapascal, then the natural frequency of transverse vibration is. Here for this case, natural frequency of transfer vibration is given by 0.4985 by root of del 1 plus delta 2 plus delta 3 by 1.27, where del 1 and delta 2 are static deflections and delta 3 is the uh, uh, del 1 and del 2 are static deflection due to point loads, and del 3 is the static deflection due to the uniformly distributed load. Here, due to the uniformly distributed load, deflection is given by 5 by 384 WL power of 4 by EI. So now substitute all these values here. 5 by 384 W is the mass into acceleration due to gravity 9.81 into the length is 1.5 meters, and here E is Young's modulus is given by 200 gigapascals, and I is given by 1.4 into 10 power minus 6. So from this we can get here it is 56 into 10 power minus 6 meters. So this is due to the UDL. Now substitute all these values in the given equation omega n, then we can get here it is 32.4 Hz, and in the option the right option is B. B is the right answer. Refer the figure below. It shows that gear wheel A with 20 teeth fixed to frame and arm C with gear wheel B with 40 teeth revolving about the gear wheel A. For 10 revolutions of arm C, the gear wheel B rotates about its axis by. Here use tabular method. So here is the given diagram. Gear A wheel, gear wheel A with 20 teeth and gear wheel B with 40 teeth, and an arm is connected between A and B. And here the gear wheel A is fixed. That means the revolutions of A is equal to 0. Now use tabular method and consider here first condition of motion, and here revolutions of element, and arm C, gear A and gear B. So first consider for the first case, arm C is fixed and rotate A through one revolution. First arm C is fixed and rotate A through one revolution, the two on clockwise direction. Okay, here arm C is fixed so that the revolution of C is 0, and here gear A rotates with clockwise direction, let us say +1, and here then gear B rotates with minus TA by TB, the ratio of minus TA by TB. Now consider coming to the second step, again arm C is fixed and rotate A through plus X revolutions, that is X revolutions clockwise. So here it is again 0 and it is X, and here it is minus X into TA by TB. Now consider add plus Y revolutions to all the members, that is arm C, gear A and gear B, so that it is plus Y and it is X plus Y and it is Y minus X into TA by TB. So this is the table, and here the total motions is equal to, this is Y and this is X plus Y and this is Y minus X into TA by TB. Okay, and here we know that the arm C is rotating and here the gear wheel A is fixed. That means NA is equal to 0, but here X plus Y is equal to 0. That is X is equal to minus Y. But here arm C, the total motions of arm C is Y, but it is given that for 10 revolutions of arm C, the gear wheel B rotates about its axis by. So here arm C rotates with 10 revolutions, that means Y is equal to 10 revolutions, and here X is equal to minus 10 revolutions. So that now the arm B rotates, that is, gear B rotates Y minus X into TA by TB. Here Y is 10 and here minus of minus 10 is plus 10, and here TA is 20 and TB is 40, which gives 15 revolutions. So here the gear wheel B rotates with 15 revolutions.